Hello everyone, welcome back to Design Learning System topic. In that we have completed the first and second topic. First topic was choosing the training experience, whereas second topic was choosing the target function and evaluation function. Now the third step in that once we know what kind of training and type of knowledge we want, we need to represent to show or make it easier for us to understand how to design a system. So first we need to represent our system properly. Third step is choosing the target function representation. Choosing a representation for the target function. Yesterday we have seen the target function and evaluation function and how to represent now. For example, let us suppose you have the square matrix. There are rows and columns. It is just simple example I am telling you what is meaning of representation. Let us suppose this rows corresponds to each board state, each of the state. These columns corresponds to moves. For example, if you are in this board state, these are the possible moves. If you are in this board state, these are the possible moves. If you are in this board state, these are the possible moves. Like that, your target function learns. Each move has some different numerical value that will be calculated by the evaluation scores. This is the simplest representation. So here we will study how to represent our target function. Here we have something called as linear function. Linear combination of the board feature. We represent in terms of linear combination. We will see for linear combination what are the variables we need. Please remember all these things. x1 is the number of black pieces on the board. x2 is the number of red pieces on the board. x3 is the number of black kings on the board. Black kings. This is black pieces, black kings. x4 is the number of red kings on the board. x5 is the number of black pieces threatened by red. x6 is number of red pieces threatened by black. We will understand what is meaning of that. See here, you have a board here, right? You have a board, you have 64 squares. So here you have pieces, right? The total number of red pieces and black pieces will be represented by x1 and x2. x3 is the number of black kings, x4 is number of red kings. x5 and x6, you understand. For example, this is the board. Let us suppose this is your coin here. This side you are sitting, your opponent is sitting. This side, this is your coin, red or black. Here two pieces of opponent are existing. As you can see in the checkers game, it is moves only in the diagonal direction. This is your piece. This piece is threatened by this piece, this piece. Are you understanding? This piece can also remove your piece. This piece also can remove your piece. So that is meaning of number of black pieces or number of red pieces threatened. Are you understanding? Hope it is clear. Next, linear combination means we are adding all those things in this equation. This is the representation. V cap of B is the function learning. We are representing x1, x2, x3, x4, x5, x6. You already know. We are assigning the weights here. What are the weights? W1, W0 to W6 are weights. You can see here W0 through W6 are numerical coefficients or weights chosen by the learning algorithm. Learning algorithm will choose how much weight I need to give it to each of the variable from x1 to x2. Learned values for the weights W1 through W6 will determine, please understand carefully, learned values for the weights W1 through W6. What will be the value of W1 to W6 will determine the relative importance of various board features in determining the value of the board. Each of these value of weight will determine the board state, at what board state you are in now. W0 will provide the just a constant to the board value. So you can see here, partial design, it is not complete yet. The task we were undergoing is playing checkers. Performance P is the games won in the tournament. Training experience is the we decided earlier only we are playing against itself. The target function we already seen, we are assigning some numerical value R. This is the linear combination, this is representation. Till now we have seen this. Now next is, once you understood the what kind of training experience you want, what kind of functions you have, whether it is target function or evaluation function, once you know the representation, here we are representing using the linear combinations of the variables and weights. Now next is to calculate a function approximation algorithm. Next we have to design one algorithm by using and inputting this data to make a system to learn or machine to learn. See, it is very easy. It is very easy that if you win the game, we have assigned the value 100. If you lose the game, we have assigned the value -100. If the game is drawn, we are assigning it is 0. Just for example, just take it that x2 is equal to 0. x2 is equal to 0 indicates that there are no red pieces. There are no red pieces on the board. That means black has won. Are you understanding? That means black has won. The value of variable black is x1. It can be any variable. There are mainly 12 pieces on the board. The value can be 1 to 12. So it is just random. x1 is equal to 3. x2 is 0. x2 is 0 because that there are no red pieces. x3 is equal to 1. x3 represents the black king. There will be only one king. Are you understanding? There will be only one king at the end of the battle. There will be no two kings. There is only one king. x4 is 0 because there is no red king. x3 is 1 because there is black king. x5 is 0. x5 is 0 because there are no pieces which are threatening each other now. So x6 also 0. There are no pieces, either black or red, threatening each other because game is won, right? There is only one piece, that is king, and some black pieces. So as game is won, we are assigning the value as V of B as 100. So it is very easy. If you win the game, then you tell me to assign the value. I can assign 100. What if we have to assign value in between? The game is not over yet. We don't know whether we are winning or losing. So that time we have something called as approximation. We cannot directly tell 100, but we have to approximate. We will see how that is. So it will be in the state. B is the board state and V train is the what is the value for that move or board state. So function approximation procedure is, first thing is we have to derive the training examples. Function approximation procedure is, first we have to derive the training examples from the indirect training experience. That moves are already stored. From that we have to derive the training examples. What kind of training examples we have to see and what value I should assign in between. Then adjust weight according to that and best fit. There is one word called best fit here. That means which help us to reduce the error. See here, first one is the estimating the training values. What value I should assign to this move? It is very easy to assign the value once the game is finished. I will assign, if the game is won, I will assign 100. If the game is lost, I will assign minus 100. But what in between? So we have to first estimate. The simple approach to assign the value is something called as V successor B. What is meaning of this? See, I am playing now. I am in some state. From here I have around 3 or 4 moves. What will be if I move this, or if I move this, or if I move this? I have 3 options. I have, for example, this is the box. From here, let us say I have 3 options to move. So if I move like this, what will be the opponent's move? If I move like this, what will be my opponent's move? And if you understand what will be your opponent's move and what will be your next move, that is the successor move. If you take that as a training value, then there is a chance of winning the game increases. I will not say you will 100% win the game, but the chance of winning the game is increases. I will tell once more. From this board state B, you have around, let us say, 2 options. If I move like this, or if I move like, these are the successor moves. These are the successor moves which will help me to beat the opponent in this state. So that will be assigned. That will be assigned as training value. You can see here, for the training value, your successor move will be assigned. Your successor move will be assigned. I hope it is clear. If any doubt, you just comment below. I will solve that in next class. So once you know the training value, variable x1, x2, xt, next you have to know the what weight you have to assign. That will come in adjusting the weight. That is according to the concept called as best fit. You have to take those moves, you have to take those weights which minimizes your error. It is like a negative feedback control system. What you do in negative feedback control system is you try to minimize the error by taking the output. Here also, by taking the successor move as the training value, whether it is helping me to win the game or lose the game, and what is my error, that we calculate something called as by squaring the error. Why we square the error? For example, if my error is 0.2, if I square it, the value will be 0.04. Are you understanding? It still reduces. So I have to square it. to reduce the error. That to find the best fit, we have many algorithms. We have several algorithms to find the weight. Which best fits, which reduces the error. For that, training value to calculate. One such algorithm, we call it as least mean square or least training square. You can see here, we reduce the error, then we update it. It is just like a negative feedback control system. I will take one very simple example. Let us say this is the pole. Here you are standing in front of that and you are hitting the stones. Right. First, once you hit first stone, you will hit here. What you will do? You have to minimize this error. So you have to reduce or square, and your weight should be according to that. Next time you hit here, next time you hit here, next time you hit here. What you are doing? You are minimizing the error. For this, we use least mean square algorithm. So this is the first move, this is the second move. This value should be assigned to this first move as the successor move to reduce the error, least mean square error. This is the V train, V cap of B, the approximation function. This is the eta or n. This is the Wi. This is the method to calculate the least mean square weight. So when the error, for example, we train the value and the approximation function is 0, that means that is the best fit. You don't have error. There is no need to update the weights. You can see here. If the value is positive, if the value is positive, the value is positive, you need to wait and update the weight increase in proportion to the value of that feature. If the value is positive, because there is an error, little error, you need to update your weight so that error is minimized. Error is minimized. If it is 0, there is no need to update the weight or alter the weight. That is meaning of updating the weight or best fit using the least mean square. This is the step of choosing the function approximation algorithm. In this you have two types. One is the estimating the training value. Second is the best fit method to update the weights. In the estimating the training values, you assign the training value as the successor step to minimize the error. How to update the weights? Using the best fit using least mean square method. Are you understanding? If the error is 0, you no need to update the weights. If the error is positive, you need to update the weight in proportion to that. Now is the final design that we will see in the next session. If you have any doubt, please comment below. Thank you very much.